Hello, calculus fans. Let's talk about the chain rule. Now we have a chain rule from Calculus 1. It gives us a rule for differentiating composite functions. So if we have y equals f of x and x equals g of t, where f and g are differentiable functions, we have a way of computing the derivative of y with respect to t. In fact, we can say that y is indirectly a differentiable function of t, and using Leibniz notation, dy by dt is equal to dy by dx times dx by dt. Now if we have functions of more than one variable, the chain rule will have several versions. Now each of them is going to give us a rule for differentiating composite functions. It's really the same idea. Now the first version we're going to talk about will deal with a case where z is equal to f of xy, and each of the variables x and y is, in turn, a function of a variable t. So z is indirectly a function of t. So we'll say that z is equal to f of g of t h of t, and then the chain rule will give us a formula for differentiating z as a function of t. And when we write out the formula, we'll assume that f is a differentiable function of two variables. So case 1 of the chain rule says that if z is equal to f of xy is a differentiable function of x and y, where x is equal to g of t and y is equal to h of t, are both differentiable functions of t, then z is a differentiable function of t, and here's a formula that gives us the derivative of z with respect to t. Now this looks a lot like the ordinary chain rule from Calculus 1, except there are two terms to add. So dz by dt will be equal to df by dx times dx by dt, but then we also have to add to that df by dy times dy by dt. And we'll show some applications of how to use the chain rule coming up next. Okay, that's all for now.